Welcome to EDU World Space.
So in this problem, we're asked to explain some variations in atomic radius. So we're first asked to look at iodine 1 minus, which is greater in size than iodine, which is greater than in size than iodine plus. Okay, and so an easy way to think about this is let's think about the number of electrons and the number of protons. Okay, now in this case, the number of protons is the same. So the only thing we're changing is the number of electrons, right? So we can rephrase this question as why does adding electrons, whoops, why does adding electrons increase radius? Okay, and the answer is because it increases electron repulsion. Because electrons are the same charge, right? So opposite charges attract, like charges repel each other. And so if you think about, you've got a basket and you try to stuff more and more electrons into it, as you add more electrons, it gets harder and harder to stick them all together because they want to repel each other. And so naturally, the radius would increase because of increased electron repulsion. Okay, so for this problem, the answer would really just can be accounted for by increased electron repulsion. In part B, looking at Ca2 plus is greater than Mg2 plus is greater than Be2 plus. So for this problem, both the number of protons and the number of electrons are changing. So it's a little trickier. We can't just logic through it as easily as we did the last one. But let's highlight these, right? And you'll notice that they're all in the same column. So maybe there's something that we can do here. Okay, because normally as you move down, moving down a group increases the atomic radius. Right. So normally, if these didn't have any charges, right, beryllium would still be smaller than magnesium, which would still be smaller than calcium. Why is that? Okay. And I want you to think back and remember that the reason for this is because, once again, of just increased repulsion. Okay. Um, I want to erase this. Hold on. And this repulsion is because instead of just adding, just one electron like we did with iodine, you're adding a whole shell. And so of electrons increases the radius. Okay. And the reason for this is because of shielding. And what shielding is essentially when you have these shells of electrons, the inner electrons decrease the effective nuclear charge on the outer electrons. Okay. Meaning that if you imagine this positive charge from the nucleus trying to pull in all these electrons, if you have a layer of electrons that's close to the nucleus, and you have another layer of electrons that are further from the nucleus, right? Those inner electrons are going to sort of um, cancel out that attractive force from the nucleus on those outer electrons, right? So as you add more shells, that shielding effect on the outer electrons becomes more and more relevant, right? And so if we were to sum up our answer in just one word, we could just say shielding, and that would really summarize the gist of this. Let's finally look at part C. Now, iron is larger than iron 2 plus, is larger than iron 3 plus. Let's drag our table down. Okay. So in this case, like with the first problem, right, the number of protons is staying the same. But this time, as you remove electrons, it gets smaller, or equivalently, we can phrase it like, why does adding electrons to iron 3 plus increase radius? You can imagine iron 3 plus would have the same number of electrons as chromium. Okay. And so as you move across this row, from chromium to manganese to iron, the atomic radius is getting smaller as you remove those electrons. And the reason for this, hopefully this looks familiar, is going to be again because of electron-electron repulsion. Okay. As you remove electrons, they repel each other less and they get pulled into the nucleus closer. So that's the problem.